Here's a quick video on rectangles. It's a special case of parallelogram. So we have our parts of rectangle. We have the sides, right? So we have AB is a side, looking at our diagram over here on the right. And AB is going to be parallel to CD. It's also congruent, okay? We have AC is parallel to BD, and they are also congruent. AB is congruent to CD, and AC is congruent to BD. Sides are the segments that connect the angles together, create the outside of the shape of the rectangle. Vertices are the corner where two sides meet, okay? So we have vertex A, B, C, and D. A vertex is where two sides meet. Angles, we have angle A, angle B, angle C, and angle D. Those are the interior parts of the vertices. So in a rectangle, they are all 90 degrees. All right angles, which are 90-degree angles, are congruent. So that means angle A, angle B, angle C, and angle D are all congruent to one another. And then we have our diagonals. And we know from parallelograms, diagonals bisect each other. So that means AE is congruent to ED, right? And then BE is congruent to EC, okay? Because we have over here, this is the point E where both of these lines bisect one another. Now in a rectangle is a special case. In fact, every single one of these segments is congruent to one another. The diagonals are congruent. So BC is congruent to AD, okay? And that's only with rectangles and then squares, which is a special case rectangle, but we're just talking about rectangles right now. All right. So, sample problem. Solve for missing sides. So based on what we know of rectangles, we should be able to solve for, this is a solve for X type problem, where in this case X is W, right? We're trying to find this. They said our perimeter is 56. Our perimeter is really just the four sides of the rectangle added together. So I labeled what I know, right? A rectangle is a parallelogram. That means opposite sides are parallel and congruent, okay? So if this right side is W, this left side must also be W. And if the bottom here is 16, the top also must be 16. So I have 16 plus W plus W. That's my perimeter. I add all the side lengths together. That equals 56. When I combine like terms, I get 32 plus 2W equals 56. Subtract 32 from both sides. I get 2W equals 24. If I divide both sides by 2, I get W equals 12. This answer makes sense. And so we could use what we know about parallelograms and rectangles to solve for missing sides. We've done some of this work with parallelograms already. All right, solving for missing angles makes it a little easier to do in a rectangle because we know all the vertices, the major vertices anyway, are 90s, okay? So like this is a 90-degree angle. D, A, and B are all 90-degree angles, okay? Another cool thing is we're given this angle here, EAD is 65. So we'll say angle EAD is 65. And I know I'm supposed to write a little m in front of here, but for the sake of time, I'm not going to do that, okay? What we know about the diagonals in a rectangle is they're congruent, and they bisect each other. So if they're congruent and they bisect each other, that means each of the bisected parts is congruent. Okay, so I have a angle EDA is also 65. That's number 2, right? Number 2. Because if these two segments here, these two legs, are congruent, that means I have an isosceles triangle. And the angles opposite the congruent legs are going to be congruent. So it means EAD equals EDA. Now, another cool thing is because of the congruency of these diagonals and the opposite sides, I have two congruent triangles here in red, two congruent isosceles triangles, and I also have two congruent isosceles triangles here in blue. And we can do a more involved proof of this later, and we will, but for now, just trust me. So to solve for angle 4, because these two triangles are congruent, angle 4 is also 65 degrees. Okay, but now we're looking for angle 3. What does angle 3 equal? We don't know yet. Well, because triangle B, oh, excuse me, not A, pardon me, BEC is isosceles. That means angle ECB is 65 degrees. That's this angle right in there, okay? I know I'm still writing in blue, but it's to contrast a little bit. So if this angle ECB is 65, how can I use that to solve for number 3, which would be ECD? ECD. Well, easy. ECD and angle ECB are complementary. They equal 90 degrees. So I know what ECB is. This is 65 degrees. We'll call ECD, we're just going to rename that number 3. And now we have one equation, one unknown. We can just solve using some algebra. Some students told me today, algebra is the easy part of geometry. Geometry is the hard part of geometry. And so angle 3 is 25 degrees, okay? And then I can fill that in. Angle 1 is also going to be 25 degrees because these two triangles are congruent isosceles triangles. And so we can do some other things too. They give us dB here. Let's switch to black real fast. dB is 24. Well, you might get a question saying, well, if dB is 24, what is CE? What does that equal? Well, if CA equals dB, oops, and they both equal 24, CE must be half of CA, which is half of 24, which is 12. So all of these actually would be 12 here. Okay. So there's a lot we can do. We can even use some trig to find out what these side lengths are here, CB, the short sides, and the long sides as well. But we're not going to do that right now. So rectangles are a special case of parallelograms. Opposite sides are parallel and congruent. All angles are congruent. The interior angles are all congruent. They are all 90-degree angles. All 90-degree angles are congruent to each other. Diagonals of a rectangle are congruent and they bisect each other, just like in a parallelogram, but in a rectangle, they're congruent to each other. And diagonals form isosceles triangles, which can be helpful for doing some proofs, as well as solving for missing side and missing angles. I hope this video has been helpful.